In this video, let's try and understand the saving investment model, and let us assume that we are dealing with a closed economy, right? And we'll try and understand both the analytical framework and the numerical framework, right? So there are several ways one can understand any model: graphical, numerical, analytical. Here our focus is going to be based on the analytical framework, and we'll draw parallels with the numerical framework, right? So in this model, our aggregate supply is represented by our production function. So the total output is a function of capital and labor that the economy has, and the assumption is that the labor and capital are both exogenous, and hence you have a bar on these variables. Now, given the capital and labor is exogenous, the output also becomes exogenous. So it's basically end up saying that let's assume that output is some number 18,000. On the demand side, aggregate demand side, you have C plus I plus G. So the consumption done by the consumers, investment spending done by the businesses, and the government spending done by the government. So C is given by a consumption function. So let's say C is given by C constant. So this part of consumption is autonomous, meaning it is not related to the amount of disposable income. And then in addition, every time you get some income after you pay your taxes, we increase, there's a plus sign, we increase by a factor of CY. Now, if you notice, of course, this is our marginal propensity to consume, right? How much is our extra ability to consume out of every one more dollar in disposable income that we get, right? So that's the consumption function. Let's make up some numbers in the numerical framework. So that say, let's say the autonomous part of consumption is 300, right? And then marginal propensity to consume is 0.8, and then income minus taxes. Let's assume taxes is 2,500. Right? We can of course substitute this 18,000 over here and get our consumption. Correct. Now the investment function is also going to have two components. That component which is not related to interest rate, and plus the component that is related with interest rate. Now remember, interest rate will have a negative relationship with investments, meaning this I subscript R is going to be negative, right? As interest rates are high, the cost of borrowing is higher, and if the cost of borrowing goes up, there is less incentive for the businesses to undertake investment activity, right? Again, we'll make an investment function numerically. Let's say investments, the autonomous part of investment is 3,500, meaning this is the amount of investments that is not related to interest rate. And then let's assume the slope of the curve of or the investment function is negative 400 R, right? So this negative 400 is basically saying that if interest rate goes up by 1%, then I will go down by 400. The government spending is just going to be exogenous, right? So the government spending is exogenous, so G is equal to G bar. Again, we are just going to make up some number, say 3,000. And then of course T is also exogenous, and we have already said that T, let's assume it to be 2,500. So here's the setup of the model, both in the analytical framework as well as in the numerical framework. Now let's look at the equilibrium condition and try to derive our endogenous variable, which in this case is our real interest rate. So in equilibrium, we know that the total aggregate supply is going to be equal to aggregate demand, which is made up of three components, C, I, and G. And so is the case with, we're just going to copy paste this over here, that we need the equilibrium condition to satisfy that the aggregate supply matches or equals the aggregate demand, which is C plus I plus G. Now if you subtract C and G on both the sides, we would end up getting Y minus C minus G equals I. And of course, Y minus C minus G equals I. Now notice this expression, the income, total income, minus the consumption done by the private people. So private consumption minus the public spending. So income minus private spending minus public spending is nothing but income minus the total spending is savings, has to equal investments. In the numerical framework, we are just now going to substitute all the values. So Y is 18,000, C is 300 plus 0.8, 18,000 minus 2,500, and then government spending is minus 3,000, so that's minus 3,000, and that is equal to our I, right? So I is 3,500 minus 400 hours. So when you solve for this, you will get R equals 3. Right? In this analytical framework, we can still follow the same steps. So we can say Y minus C, that part, constant part or autonomous part of consumption, plus the MPC Y minus T minus G, that is equal to the autonomous part of investments or constant part of investment function, and plus I, which is a function of R. Okay? And so if you have to solve for R, that would be nothing but this entire expression that we have, Cy y minus t minus G minus IC divided by, remember both the sides, this is investment, how sensitive the investment is to interest rate. So this is IR is a slope coefficient, and so it's IR multiplied by R. So you divide both the sides by IR, you get your real interest rate. In the analytical framework and in the numerical framework, given the numbers that we have used, you get interest rate equals 3%.